So hopefully this video is not coming too late. I know some of you have already taken the right triangle trick test, but there is some more classes who's going to take this test. So I like this question a lot. So let's go over this problem. This is saying an Iron Man sets a course to swim 250 degrees to a lighthouse that is located 10 miles away. But due to unexpected weather conditions, she gets off course at 225 degrees for 4 miles. Find the bearing, compass, and directional, and the distance she needs to swim to correct her course. Let's go step by step here. Let's suppose the Iron Man is over here. And whenever you have these bearing problems, you have a from and a to, right? For that from, you need to make sure you're drawing a north-south and east-west line always. Yeah, so I'm going to draw my north, south, east, west line over here. And it's best to draw these like really big as much as possible. And she sets a course 250 degrees. 250 degrees, you know, course is always clockwise from the north-south line. So you know this must be like, okay, from here, clockwise, no? If this is 270, 250 is like somewhere here. Yeah. And she's going to go 10 miles, or she's setting the course for a lighthouse that is 10 miles away. Now, if this whole thing is 250, you know this remaining thing is 20 degrees over here, 20 degrees. Okay, so let me just like highlight that. That is 20 degrees. It's always good to put these the leftover angle and stuff. Otherwise, you know, you'll kind of get lost in the problem. Yeah. Now, because of turbulence, she gets off, or because of, you know, not turbulence, but weather conditions, she gets off course at 225. So from here, she's swimming, but she's getting off course at 225, right? 225 for 4 miles. Let me draw that as scale. So let's say this is about 4 miles. Okay, and the 225 means, you know, if this whole thing is 180, 225 means 225 minus 180. This, you know, this little angle over here is 45 degrees. Whoa. All right. Looks ugly, but this is 45 degrees. I'm just going to like kind of highlight that. Okay, that is your 45 degrees. Awesome. Now, you want to find the bearing and the distance she needs to swim to correct her course. So basically from here, she's going to swim to the destination she had in mind earlier. What is going on? There you go. And you want to find the bearing and the distance. So one thing you got to find is the distance. So you want to find this X value. And you can see now you have a triangle. And basically, if you have this angle here, it is your, whatchamacall, SAS situation, right? And you know, if you have an SAS situation, you can use your law of cosine. So let's see how we can find that angle measure. Whoopsies. What? No. Okay. So from here to here was 250, and from here to here was 225. So that means that middle angle must be 250 minus 225, or 25 degrees. Okay. So this angle here, you know, is 25 degrees. So you have your SAS situation, and then therefore you can use your law of cosines, which is x squared is equal to 10 squared plus 4 squared minus 2 times 10 times 4 times cosine of 25 degrees. And let's see what that is. You know, law of cosines is simple. You can just literally just plug it in into your calculator. Make sure your angle, the mode is in degrees. Yes, mine is in 100 plus 16 minus 2 times 10 times 4 times cosine of 25. Okay. And then you do square root of that, and I get 6.59. 6.595 miles. Better to get as many digits as possible because, otherwise you'll have a lot of round of error. Awesome. So you have your X now. Now, you were asked to find the distance, which is your 6.595 miles, but you need to also find the bearing. So to find your bearing, again, you want to find your bearing from here to the lighthouse. So wherever you have your from, you need to make your north-south line. I should have made this in a different color, so it's kind of easier. I'm just going to draw over it. So this is your original earlier north-south line, and I'm going to make another one because we're asked to find the bearing at from this point. Okay. Now, the key about these questions is that whenever you have north-south lines, those north-south lines are going to be parallel. So always, whenever you have, these kind of problems, you need to put, if you have two lines that are parallel, the alternate interior angles are congruent. So you need to kind of do that because that's going to most likely help you. So you can see this is a 45 here, which makes this a 45 degree because their alternate interior angles formed on parallel lines. So I'm just going to kind of like show that here. What else? Do we have anything else that's relevant? I don't really see much more that is relevant. This is 45, but I know that already. It's not really, doesn't seem like that's going to help. So I'm going to keep that over here. Okay, now I want to find the bearing. So I need to find this angle. Let's choose a different color. Okay, you want to find this angle. Yeah, you want to find that angle. So to find that angle, if you think about it, well, you kind of need to find, for this problem, you're going to need to find this angle, and then you can subtract some stuff from here. Like, that from this is a 90-degree angle, this is a 45-degree angle. So if you have the big angle of the triangle, and if you subtract 90 plus 130, sorry, I'm thinking, fast. So 90 plus 45 is 135. So if you subtract that 135 degrees from this big angle, you can find, you can find this angle. And if you find that angle, then you can subtract that angle from 90 to get your teal angle, which is the angle that you need. Too many things going on here, but that's what you do, okay? So you need to find this angle measure. I'm going to label this triangle ABC now. Basically, in order to find that, you need to use your law of sines, or you could use your law of cosines too, because no, you can't do that. Yes, you can, because you have an SSS situation. So you can use your law of cosines. I'm just going to use my law of sines, okay? Because that's what most kids are going to do. So I'm going to use my law of sines to find angle A, okay? So I know law of sines goes sine A over the opposite side, 10, is equal to sine 25 over the X value that we found earlier, which is 6.595. And so that is... So that is, so this one's a little tricky, huh? Because if you do, so you're going to get sine A to be 0.64. And if you do sine inverse of that, you're going to get angle A to be 39.85 degrees. But that does not make any sense here because you have, like, if your angle A is 39.86 and you already know the angle C is 25, then angle B is going to be an obtuse angle. And angle B is opposite 4, which 4 is not the smallest side here. Is not the largest side here. It's the smallest side. So you're going to expect the smallest angle there, right? So this largest side in this triangle is 10, and the angle opposite the largest side must be the largest. So angle A must be larger. So 39.85 must not be the angle here. So you need to do 180 minus this angle. And if you don't understand that, that's because, really quick, I'll explain it, but that's really not for this topic. The reason why that is because, you know, if sine is positive, you could have an angle in the first quadrant or the second quadrant. So, you know, when you do sine inverse, you're going to get an angle in the first quadrant. So if you want to get the angle in the second quadrant, you need to do 180 minus the reference angle to find your angle in the second quadrant. So that's essentially what we are doing, right? So when you do 180 minus 39.85, you're going to get your answer as 140.15 degrees. So that's angle A. Yeah, now that angle A is its whole angle, but you know this plus 45 is 135. So that angle over here, which I'm going to color with a different color. I'm running out of colors here, guys. So let's say, you know, if I want to find that green angle, then I need to do 90 plus 45, which is 135. Angle A, the green angle, is equal to angle A minus 90 plus 45, which is 135. So 140.15 minus 135 degrees, it is going to kind of get the exact angle. That's like 5.15 degrees. So your green angle is 5.15, but I need my teal angle to find the bearing. So if I want to find the teal angle, I know this whole thing is 90 degrees. All I need to do is, you know, to find my bearing, the teal angle, I need to do 90 minus 5.15, and that is going to be your answer. So I'm going to get, as an exact answer, I'm getting 84.85 degrees, okay? So your bearing, directional bearing, the way you would write your directional bearing, you would write, always start with north-south. I'm looking at from the south, so it's going to be south, 84.85 degrees, and you're going to the west side, correct? This is going to the west side. So south 84.85 west, or you want to find your compass, your compass or your course bearing. That always you go from your north-south line clockwise to this. Yeah, so that's essentially 270 minus the green angle. So 270, oh my God, my pen is flying. So 270 minus the green angle is going to be our course. So green angle was 5.15. So that is, no, I want the 264. 264.85. So about 265 degrees. That's your course. Okay. All right. So hope that was helpful. Stay tuned for more. I plan to put one video per like quiz or per test to help. And if you like the video, give me a like, subscribe, and all that stuff. All right. Take care. Bye-bye.